Hello friends, how are you? I hope you all are well. Today, this video is the continuation of the previous video, reflection of a light. In my previous video, I explained how the image formed in a plane mirror and some concepts related with the topic reflection of light. So today in this video I am going to explain about spherical mirrors. Which is the important part of the topic reflection of light for your 10th class. So, what they mean by spherical mirrors? Previous videos I explained what is plane mirror, but in this topic mainly we are learning about the spherical mirrors. So what is spherical mirror? How many types of spherical mirrors? How it works? What are its applications? All these things we cover in the topic reflection of a light. So spherical mirror. You see that suppose this is a hollow sphere of glass. Hollow sphere of glass. Now, suppose from this glass I shall take one part. See that. Suppose end to end, I am taking a part of a hollow sphere which is made out of a glass. Now, this part MN, it has two surfaces. This one we say inward surface, we say it is concave surface. This outward surface, this is convex surface. You see that? Now, this is one surface outward, bulge out surface, that is the convex surface. Inward, that is the concave surface. That means I have taken a part of a hollow sphere of glass. This part has two surfaces. One is concave surface, inward surface. One is outward surface, that is the convex surface. Suppose this concave surface, I have polished it, or you can say it is painted with reflecting substances like silver. See here, in this case, outward, this surface, it is painted with silver, and this oblique line, it represents the back side of the mirror. That means the front side, the bulge out surface, means convex surface, is the polished surface. It behaves like it is a mirror. So, this mirror we say convex mirror. Now, if the outer surface is painted with silver, then this one becomes a concave mirror. Listen carefully. both convex mirror and the concave mirrors together, we can say a spherical mirror. Spherical mirror. Listen carefully. Spherical mirror means it is a part of a hollow sphere of glass. I can write that a part of a hollow sphere of glass with one reflecting surface. Reflecting surface in the sense one surface coated with silver. Reflecting surface means one surface coated with reflecting substance like silver, aluminium, etc. This is called the spherical mirror. A part of a hollow sphere of glass with one surface coated with silver. Because silver is the best reflecting substance, we can say it is a spherical mirror. So spherical mirror, already said, two types of a spherical mirror. One is concave mirror, one is convex mirror. You see that? Okay. Now I have taken a part MN. I have taken a part of the hollow sphere. Now this surface is coated with silver. Now I can say this is convex mirror. Now M dash, I have taken this portion. Suppose this outer surface, bulge out surface painted with silver. So this is concave mirror. That means the spherical mirrors are two types. One is concave mirror, one is convex mirror. Then what is the definition of convex mirror or concave mirror? A concave mirror is a part of a hollow sphere of glass with its convex surface coated with silver, or I can say that its convex surface is polished. If the convex surface is polished, then we will say concave mirror. Convex mirror, just opposite. So what is the convex mirror? So convex mirror means it is a part of a hollow sphere of glass with its concave surface. Means inward surface is coated with silver, or you can say inward surface is polished. Then we say that is the convex mirror. So Spherical mirror, two types. One is convex mirror, one is concave mirror. Now let us discuss about the terms, some of the important terms related with spherical mirrors. Important terms related to spherical mirrors, very important. All these concepts, the terms, what I am explaining, listen carefully. Okay, this is very essential. These are the ABC of the topics. See here, first point. You see that either it is a convex mirror or it may be a concave mirror. Suppose this MN. See here, actually we are taking this mirror from the part of a hollow sphere of glass. So this is the M, this is the N. Suppose this outer surface is painted. So this is concave mirror. Similarly, suppose M dash N dash, this part we are taking, its inner surface is coated with a silver polished surface. Okay, so this is convex mirror. Now listen carefully. So first point, first terms. Pole of the mirror. The midpoint of the spherical mirror, whether concave mirror or convex mirror. M to N is the mirror size. Suppose this point is the pole of the mirror. This is the pole. It is represented by the letter P, whether it is there or so. It is a point on the surface of the mirror. Okay, the midpoint of the spherical mirror. It is a point on the surface of the mirror. This is the pole of the mirror, whether it is the convex mirror or concave mirror. So it is a point on the surface of the spherical mirror, whether it is the concave mirror or convex mirror. It is a point on the surface. This is about the pole of the mirror. Second point, center of curvature. Center of curvature denoted by the letter C. See here, this mirror, once it was a part of a hollow sphere of glass. This point is the center of the sphere. So the center of the sphere of which the mirror is a part, center of the hollow sphere of which the mirror is a part. This mirror is a part of the hollow sphere. So hollow sphere having a center. This is not the circle. I am telling about the sphere which is three-dimensional, looks like a football. So its center, it is in a football, its center, it is not a part of the bladder. You can say like center of gravity. So the center of the sphere of which the mirror is a part is called the center of curvature. Next one. So this is about the center of curvature. Next point I am going to tell about the radius of curvature. See, radius of curvature. The distance from center of curvature to the pole of the mirror. The distance from center of curvature to the pole of the spherical mirror is called radius of curvature, whether it is the convex mirror or it is the concave mirror. But the distance from center of curvature to the pole of the mirror is called radius of a curvature. Next point, principal axis. Principal axis. Principal axis, in fact, it is a imaginary straight line. The imaginary straight line which passes through or joins or which passes through, you can write passes through pole and center of curvature. Thus, imaginary straight line which passes through pole and center of curvature. See that this is the pole. Suppose this is the convex mirror. This is the center of curvature. This line is called the principal axis. This is the imaginary line which passes through center of curvature and pole of the mirror. That is called the principal axis, whether it is the concave mirror or convex mirror. Next one. Very important point. Focus. Okay. Before focus, one more point I shall tell, that is about the aperture, or we can say size. The reflecting portion of the mirror. Reflecting portion of the spherical mirror is called size of the mirror. That means in this figure, M to N or N dash to N dash is the aperture or size of the mirror. Next important point is that focus. Listen carefully. Focus. See here. Suppose this is a concave mirror. This point is the pole of the mirror. This is the center of curvature. I have joined. This is the principal axis. Here, you think that some light rays coming from far away. Light rays coming from far away. See here. Light rays coming from the far away. Those light rays comes from the far away, comes from infinity, you can say. It considered as the parallel beam of light rays. So I am telling those rays are close and parallel to the principal axis. After incident, they reflect. During reflection time, they follow the laws of reflection. Okay, in my next video, I can say, okay? See, now suppose this incident ray, it is also reflecting. This ray, this is also reflecting. This ray, this is also reflecting. All these reflected rays, they are meeting at one point. How to draw this reflected ray based on the principle of a laws of reflection, in my next video I shall explain. Today just I am telling about the terms related with the spherical mirror. So in this case, this point is called the focus. So I can say it is a point on the principal axis to which all the light rays, those are close and parallel to the principal axis, converge after the reflection. That means those rays are coming close and parallel. Close and parallel, why I am telling, suppose a light ray will come like this. Will it converge here? No. So that's why I said that it is a point on the principal axis through which all the light rays, those are close and parallel to the principal axis, converge after reflection. That means after incident on the surface, they reflect. The reflected ray passes through a point. That point is called the principal focus, or shortly we say focus, or we say that is the focal point. That is the focal point. Now you see that how it is justified. Listen carefully. One question comes to my mind. Can the laws of reflection applicable in case of the spherical mirrors? Yes, it is applicable in case of the spherical mirror. But one problem is there. What problem? Suppose it is the plane surface. It is the plane surface. This is the incident ray. Easily we can draw the normal, and we can draw this is the reflected ray. In lower classes, you know, with the help of plane mirror, how to draw the angle of incident and angle of reflection. So this is angle of incident, this is angle of reflection. But in case of a spherical mirror, it is a little different. What different? You see that. Now, how to draw the normal to the spherical mirror. Thereafter, I shall make more clear information about the focus. Okay, so listen carefully. Now suppose this is a rubber. Okay, on this rubber you fix some iron nails. You see that this iron nail all are normal to the surface of the rubber. Now if I bend this rubber, you will find that this iron nail pointing towards a common point. If I extend that, you will get one common point. That common point is the center of curvature, and you see that these are the normal to the surface. That means this is a normal, this is a normal. That means I can say that the straight line which joins center of curvature to any point on the spherical mirror is a normal. Normal. The straight line. The straight line which joins the center of curvature to any point on the curved surface. Any point on the curved surface is called normal. That means line from center of curvature to any point, whether it is the concave mirror or convex mirror, does not matter. If we join, that one will represents the normal. So when I explain about the focus, see here once again, this is the concave mirror, this is center of curvature, this is the pole. Okay, this is the principal axis. Suppose one light ray comes here, this is the incident ray. Now I am joining this one. This one is the normal. So we know that angle of incident is equal to angle of reflection. Here how much angle? I shall draw the same angle. That means this is the incident ray, this is the reflected ray. Similarly, suppose this is the incident ray, this is the normal. Line from center of curvature to any point on the spherical mirror is a normal. So this is the incident ray, this is the reflected ray. See that both the reflected ray, they are meeting at one point on the principal axis. That point is the principal focus or focus. I can say this is the principal focus, or we can say focal point. This is the case of a concave mirror. So what about the convex mirror? See here. Suppose it is a convex mirror. Now this is a convex mirror. Now this line is the principal axis. This is the center of curvature, this is the pole. This is the back side of the mirror. This is the convex mirror. Convex. This is concave. Suppose one light ray comes here. This is the incident ray. Here to here I am joining. This is the normal. So we know that it will follow the laws of reflection. This angle how much? It will reflect by making same angle with the normal. That means if I extend this one virtually, if I extend, it is meeting at this point. Similarly, suppose one more light rays coming from this side. This is the normal. Okay, this is the normal. So this angle how much? It will make same angle, it will reflect like that. So if I extend this, they are meeting at this point. This point is called the focus. Now you see both the figure. In this case, what is happening? the light rays, those are close and parallel to principal axis. All the light rays after incident, they are reflecting through a common point on the principal axis. Here, all the light rays, those are close and parallel to the principal axis. After incident, they are reflecting, however, they are diverging from a common point. It appears that they are diverging from a common point. This point is called the principal focus or focus. So, either the concave mirror or the convex mirror. All the time, the principal focus will be on the principal axis, and you will find that pole to focus, this is called the focal length. Focal length. Okay. So, P to F how much? F to C also that much. So, P to C, we know this is the radius of curvature, and P to F, this is the focal length. R stands for the radius of curvature, F stands for the focal length. And you observe that this point will be midpoint between P and C. That means I can say that this radius of curvature is 2 times of a focal length. Now, let us write what is the definition of a principal focus. So, listen carefully. Principal focus. It is a point on the principal axis to which all the light rays close and parallel to principal axis. It is a point on the principal axis to which all the light rays close and parallel to principal axis. Either converge or appear to diverge. After reflection. See here. Both the definitions I have combined. I said it is a point on the principal axis to which all the light rays close and parallel to principal axis either converge or appear to diverge after reflection. That means the reflected rays either converge or appear to diverge. So it is a point on the principal axis. Okay. So next point I said focal length. Focal length. The distance between pole and focus. It is denoted by the letter small f. Focus is the capital F. Focal length is the small f. So, f is in between P and C. Then I can say that relation between R and F. R is 2 times of F. That means P to C is the radius of curvature. This is radius of a curvature. Here to here is the focal length. Here to here f, here to here also f. That means r is 2 times of a f. Radius of curvature 2 times of the focal length. So these are the terms associated with the spherical mirrors. So in my next video, I shall explain how the image formation takes place in a plane mirror, and many more things we'll learn in the upcoming videos. Until then, bye. Thank you.